Hello everyone. In this example, we're going to learn how with a minimization problem, we use the graphical method to find the optimal solution. So with these videos, we're continually building on the work that we've previously learned. So to get to this point, there was a lot of stuff that we already had to know how to do beforehand. We had to know how to create our mathematical model or our linear program. From there, to translate that into the graphical model, where we first graph the constraints, followed by finding the feasible region, and then after finding the feasible region, we then graphed our objective function in order to find the point of our optimal solution, which is where we are now. So if any of that does not make sense, please consult those prior videos. So with all that work already done, we have gotten ourselves to the point where we found that the intersection between constraint 2 and constraint 3 was the point at which we will find our optimal solution. And again, my big suggestion, before you go and solve for this mathematically, let your eyeballs give you an idea of what the answer should be. We don't trust that this is going to be the exact answer, because there could be many decimal places involved in my answer. The answer doesn't have to work out to nice, even numbers. Okay? There could be many decimal places with that final answer, but this should give me an idea of where the math will eventually lead me to. So we know our intersection point is right here at that intersection of constraint 2 and constraint 3. And if we follow that point directly over to our y-axis and directly down to our x-axis, we should see that it appears that we're going to use roughly 2 pounds of fertilizer B and 15 pounds of fertilizer A. But again, we don't write that as our final answer. We go and do the math to make sure the math works out properly and backs up what our eyeballs are seeing. So now remember, one of the keys to locating the optimal solution with the use of the graphical method was to know that it happened where constraint 2 and constraint 3 met. So as I'm going to solve for these values, constraint 1 doesn't matter. I want to deal only with the equation of constraint 2 and the equation of constraint 3 in solving for this point here. So just looking back for a second at our linear program, we are looking at here constraint 2 and constraint 3. But once again, we are not going to deal with the inequality, deal with the greater than or equal to portion of it. We are going to set this to be an equation, set it just equal, much like we did when we plotted those lines on the graph. So constraint 2 and constraint 3, again, setting them to be equations instead of inequalities. We have 2a plus 3b equals 36 and 2a plus 5b equals 40. Now, once again, like we learned in our last video, is I can choose either variable, a or b, and I can choose either constraint, 2 or 3. It doesn't matter which variable, it doesn't matter which constraint. I simply need to choose one variable and one constraint that I'm going to isolate for. So no matter if you choose something else, you should get to the same answer in the end as long as you do your math right. I just happen to choose constraint 2, and I'm going to rearrange and isolate for A in constraint 2. So keep in mind, right, this is constraint 2, this is constraint 3. So rearranging and isolating for A, first I had to subtract the 3b to the other side and then divide by 2. Now that I've isolated for A in constraint 2, I will now need to sub that into the opposite constraint. I will now need to sub that in to constraint 3. So anywhere I see A in constraint 3, I'm going to replace with 36 minus 3b over 2. And now I simply have an algebraic equation with one variable. I can rearrange stuff to solve for b. So working through the equation, eventually I get to b is equal to 2. And again, I get really happy because that's roughly what my eyeballs were telling me. But I didn't assume it was 2. This could have been 1.9 or 1.8 or maybe 2.1 or some decimal with this. In these first examples, I have chosen numbers where the answers are working out nicely. but that does not need to happen in the real world. These answers could have many, many decimal places associated with it. Here, it was quite friendly for me and worked out nice where I got to b was exactly equal to 2. I'm now going to take that value and sub the value of b is equal to 2 into either of those initial constraints. So subbing in b is equal to 2 into my constraint 2, 2a plus 3 times 2 equals 36. And if we shuffle stuff around and do the math there, what we should find is that a is equal to 15. And again, the math has backed up exactly what my eyes are seeing. And here we get that in order to minimize costs for this garden shop, we would use 2 pounds of mixture B fertilizer and 15 pounds of mixture A fertilizer in order to minimize the cost as much as possible. Thank you. Please email me with all of your questions.